super excited today to have Felice, who is the Director of North America and Continuous Improvement at the Hershey Company. And with that, Lou, you can take it away.
Okay, well, good evening, everyone. It's nice to be with you this evening to talk about STEM careers at the Hershey Company. So this is the agenda. We're going to talk about really focus on STEM careers at Hershey and a little bit about STEM and students. So, but first we have to start with a question. So Hershey's annual milk chocolate production requires the equivalent of a full week of milk output from how many cows? Does anyone want to take a guess as to how many cows? Okay, we have 500. We've got 10,000. Your guesses need to go up a lot higher. Okay, 2 million. Anyone else? More than one. There we go. All right, let's see what the answer is here. It's 900,000 cows, or 2 times the total cow population of Switzerland. So someone said 1 million, so that was pretty close. That's pretty good. You should congratulate yourself. If we were live, you'd have a candy bar now, but we'll have to wait till the next live session. So my name's Lou Felice. I'm director of the North America Continuous Improvement team at Hershey. I do have a BS chemical engineering degree from Drexel, and I am a licensed professional engineer. And I've been working at Hershey for 34 years, and I've worked in most of the technical functions that exist in the Hershey Company. And I just love Hershey. It's a great place to work. It's a great town. If you have the opportunity to visit, I highly recommend it. STEM careers at Hershey primarily fall into one of these groups or functions. So we have research and development, process development, process design. You see a lot of process in the functions, process optimization, then there's plant engineering and project management. And I'll just spend a little bit of time talking about each of those. So new product development or new technology development typically has individuals with these following degrees: engineering, materials science, or packaging science. There is such a degree. Very few schools have it. RIT and Michigan State and Clemson are the top 3. Not material science, but one that specializes in packaging materials. Food science, chemistry, microbiology, and biology. And the type of work that they do is product innovation, product characterization. We have sensory science, nutrition, and regulatory. And typically the type of work they do is they're evaluating and developing new technologies, new equipment, new processes, and new products. And you can see on this page some of the new product innovation that we've released in the past several years. And it's amazing how much technology, engineering, food science goes into developing new products and manufacturing products in a large scale production facility. The individuals that work in this function, definitely rely a lot on their technical education and background. So then process development is all about developing a manufacturing process and commercializing it. And that's typically done by chemical, biological, or mechanical engineers. It's very process oriented. And if you could imagine the the main ingredients in milk chocolate are sugar, cocoa butter, cocoa powder, and milk. And if you were to just take those raw materials and throw them in a bowl and mix them up, by no means do you have milk chocolate. So there's a lot of processing steps that are required to take those raw materials and receive them in huge quantities and convert them into a finished product. And so that's what the process development team would do, is figure out, what's the most economical way to do that, in a very large scale situation. And they work on developing manufacturing processes, defining equipment types, establishing operating parameters and tolerances, developing specifications, and conducting pilot scale testing as part of the scale up process. And there's a lot of engineering calculations that must be done to properly design a process. And now it's time for another question. How many Hershey Kisses does the Hershey Company make in one day in Hershey, Pennsylvania? $70 million, $500 million, $50 million, $2 million, $1 million. I'm seeing lots of different answers. This is great participation, by the way. So it's 70 million per day, which is a lot of Hershey Kisses. That can stretch from New York City to Los Angeles. So there's a lot of people that eat a lot of Hershey Kisses out there. So then there's process design, and that is where typically it involves a much larger cross-section of engineering, chemical, biological, mechanical, who typically work on the process equipment. But then we have electrical and controls because there's a lot of automation and sensors in a process, and the control systems. There's civil engineering from the standpoint of building fabrication if we're building a new facility, and mechanical design when it comes to layouts and doing AutoCAD type work. So those are the type of degrees or STEM fields that would work in a process design. And this is a very tedious and detailed job where detailed equipment specifications and control algorithms are designed. As I mentioned, building design and construction, process layouts, installation and startup is also part of the role when we're putting in a new process and designing a new process. You can see this is just an example of heat transfer calculations that might be done to properly size a heat transfer vessel. And this diagram in the upper right is called a piping and instrumentation diagram that the process engineer will put together, which is really the blueprint of the process and defines and links the control system to the process. So these would go hand in hand because this is a continuous evaporator that's used to make caramel, and you need to do these calculations to properly size it and make sure you're making the product that you want to make. And process optimization is really working very closely in our manufacturing facilities on existing installations to improve their manufacturing process. And once again, it's mostly engineering, but there's also some food scientists and chemists that work in this space, knowing relationships between the process and the product. And several of the areas that they might work in would be applying new technology to a manufacturing line, new equipment, increasing the capacity of a production line, reducing waste or variation, adding automation, or using what's called Lean Six Sigma methods, which are statistically based methods to accomplish waste reduction, variation reduction, capacity increases. And then we actually have technical roles in our manufacturing facilities. So we'll have chemical, biological, mechanical engineers, electrical and controls engineers, and food scientists and chemists working in different areas in our manufacturing plants. We have plant engineering staffs that maintain the facilities and the operations, and you'd find these technical STEM backgrounds in quality assurance as well, even biologists. So in just about every facet of the company, you'll find these STEM educations. Project management is really all engineering disciplines and all science degrees will could be working in this field. And project managers are really just very well organized, and they're responsible to deliver a project, within budget, within schedule, and ensure that they have all the resources to complete their project, and the project meets all the design requirements. It could be what's called a capital project, which is overseeing the purchase and installation of new equipment or buildings or financial capital. But it can also be just a general project type management, managing innovation projects, IS projects, or we call that information security, but information technology, IT projects, projects to increase capacity, or even change management projects. So now it's time for another question, and I'll pull the chat up so I can see. What brand did Hershey acquire recently? Any guesses on this one? I might have. Oh, look at that! Someone nailed it. Damian Musk. There we go. Dots Pretzels. You either like to eat Dots Pretzels and recognize them from the picture, or you read the news. So this was one of our more recent acquisitions. Just closed the end of last year. And then we actually have an advanced technology team, and that's mostly engineers, but they work on advanced technology. And this is a photo of a automatic palletizer. You can see there's cartons coming in, and this will put the cartons on a pallet and build a pallet. But they will work on new equipment design. And what's really popular now is machine learning and autonomous manufacturing, and it's called Industry 4.0 in the manufacturing industry, but it has to do with connecting everything to the cloud with respect to a manufacturing process, pulling real-time data and actually letting the cloud algorithms control the production line and learn from all the interrelationships of the data that it receives, which a human can't really discern all those interrelationships. So this is the newest area of where manufacturing is going, is this Industry 4.0 advanced technology, autonomous manufacturing. And data science is another emerging field. This is probably one of the most popular fields, or highest demand degrees. And the typical degrees that employees in this field would be a data analyst, data science, computer science, applied math, statistics, finance, even psychology, because there's a lot of statistics and math in psychology. And at Hershey, we have data scientists like throughout the organization in all these different functions: human resources, engineering, finance, marketing, sales, IS and IT has quite a few. So that's really an emerging field that didn't exist, say, 10 years ago. We didn't have careers called data scientists, but heavily STEM oriented career. So just a little bit about STEM and students. Whoops, I am sorry about that. So I always, try to suggest that students embrace STEM, encourage your students to embrace it. Students that typically would have an interest and propensity for math and science. They're naturally analytical, good problem solvers, naturally inquisitive, and have a good work ethic, because typically the STEM educations require a little more work than, say, some of the social sciences. And locally, we have resources that we do educational outreach with local high schools. We do shadow days at the Hershey Company. We have a scholarship that's available. So if anyone's online and is in high school and is in the local area, you can feel free to contact me, and I can get you connected with these, although we haven't done a shadow day in several years because of COVID. But so, as I mentioned before, chemical engineers specialize in the conversion of raw materials into finished products. So, you know, these are the three major components. You've got sugar, you've got milk, and this is actually the inside of a cocoa bean. These are what we call the nibs, or the bean. So those are the major components of milk chocolate. And as a process engineer, we know the interactions between these raw materials and the finished product, and the process, and how to convert them properly. So, you know, Hans is going to talk a lot about the processing of cocoa beans from the plantation to its what we call in-process materials of either cocoa butter, cocoa powder, or chocolate liquor. And then this would be taking those raw materials with milk and sugar and mixing them and refining them, which is creating a very fine particle size, and then creating your finished liquid chocolate batch in some sort of a mixer that we call a conch. But melted chocolate is actually a suspension of solid particles dispersed in a liquid. So you've got sugar, cocoa, and milk solids in a milk chocolate, and cocoa butter, milk fat, and emulsifiers. These are typically what your milk chocolate is made of in a continuous phase. Liquid above 105 degrees and solid below. And I don't even get into this, but one of the interesting things about the cocoa butter is it's polymorphic. So it will crystallize in multiple shapes of stable cocoa butter crystals. And there's a process we use called tempering, which is taking the liquid chocolate through a sequence of specific temperatures and with shear to create the most stable seed crystals, so that when you cast it into its shape, it will solidify properly, have a nice gloss, a nice snap, melts nicely. So viscosity is a very important principle in chocolate making, and that's really used. It's a physical property of all materials, and it's the resistance to flow. And water has a very low viscosity. It flows very easily. You pour some on the floor and it goes everywhere. Ketchup, honey, and melted chocolate have high viscosities and require energy to get them moving. So depending on what we're manufacturing, we have different viscosity specifications for chocolate. So when we're making a drop kiss on a belt, we have a depositor that takes this chocolate, and as you can imagine, it's very thick, because when it's deposited onto the belt, and it's probably 97%, like the fat is probably 97% liquid in this phase, but it's so thick that it just stands up to the point where the tip will stand straight up. And that is what we want for manufacturing a drop kiss. When we manufacture a bar, this is cast into a mold, so you don't want it to be thick. It has to be very low viscosity, so it spreads throughout the mold, and the air bubbles can be removed, and it fills the whole mold nice and evenly, so you get a nice bar. And so we can manipulate the viscosity in chocolate, and the different ways are, you know, temperature will impact viscosity. The amount of temper will affect viscosity, as well as the amount of the fat, the amount of fat, the liquid phase in the dispersion, and also using emulsifiers, which are ionic molecules that will kind of bind the water to the oil to reduce the surface tension between the two and reduce the viscosity. So I kind of covered some of this, but emulsifiers are used in a lot of food products, such as margarine and salad dressings, because it does help keep those immiscible liquids and solids in solution. And in chocolate, one of the most common emulsifiers is soy lecithin. It comes from soybeans, and it helps the solids stay in suspension in the fat phase, and it makes it very flowable. It has about a 10-to-1 effect compared to say fat. So for every 10 pounds of cocoa butter we'd have to use, we could put in 1 pound of lecithin and get the same viscosity reducing effect. And the way it works is because there's a fat loving end and a water loving end, and that just binds, helps keep everything in suspension and reduces that surface tension between the, any water that's in the system and the fat. So that was my quick, very quick overview of some of the technical concepts in chocolate manufacturing.
Thank you so much. That was fascinating. And there are definitely some questions we've been collecting on our end. How, like when you talk about these processes, how applicable are they to other industries? What other industries, like off the top of your head?
I think there's a lot of processes within confectionery manufacturing that are translatable to other totally unrelated products. We use evaporation, crystallization, heat transfer, fluid dynamics. So some of the basic on a process side from that respect, they're translatable. What I found interesting, I toured one of our local newspapers when they were printing newspapers, and the pumps they used to pump their ink were the same pumps that we use to pump our chocolate, because from a viscosity and they're a suspension of, pigments in a fluid, it's all the same. So it's really interesting when you look at that. So yes, very translatable.
Where you're seeing some of these new jobs like data science and automation really coming into full force?
I think data science is everywhere, and even in non-manufacturing industries, data science is big. It's big in marketing, always trying to, you look at all the consumer information that all these social media websites collect on you, and Google, and so data science is huge, I think, just in any business, and in any manufacturing facility that's really staying on top of the technology, and where making sure that they're going to be ready to be one of the most efficient manufacturers in their business. They are investing in what I call smart manufacturing, or Industry 4.0. Some of the smaller mom and pop, family-owned businesses might not be doing that, but it's going to be across any manufacturing industry. All manufacturing industries that'll be looking into Industry 4.0, smart manufacturing, autonomous manufacturing, because that's the wave of the future.
Thank you, Lou, for speaking with us today. I have to say, a lot of comments in the chat about how they did not know how interesting chocolate could be. So thank you both for presenting. I also want to thank our sponsors, which are the Benedum Foundation, Virginia Department of Higher Education, Illumina, BAE Systems, Broadmoor Charitable Foundation, Akamai Technologies, Aerojet, Rocketdyne, Equitrans, Midstream, Jacobs Engineering, Lockheed Martin, and TC Energy Foundation.